Do you believe a simple pencil can be turned into a mini welding tool that actually works? Hello everyone! In today's video, I'm going to transform this pencil into a surprisingly powerful tool that can help repair broken items around your home. It may look simple at first, but the result is much more impressive than you'd expect. Stay with me until the end, because what you're about to see is really worth it. Let's begin with the pencil. Take a sharpener and carefully sharpen one end of the pencil. Once the graphite core is exposed, cut a short section from the tip. Then remove the wooden casing around it so you are left with a solid graphite rod. This graphite core is the key part of the tool. Graphite conducts electricity, but it also has a relatively high resistance compared to metal. That resistance is important. When electric current passes through it, the material heats up quickly. At the same time, graphite can withstand high temperatures without melting easily. That combination makes it ideal for generating heat in a small area. Make a small groove along the graphite rod. This groove gives you a place to secure a wire connection. Without it, the wire could slip off during use. Next, take a wire that has an alligator clip on one end. Strip the insulation from the other end to expose the copper strands. Wrap those strands tightly into the groove on the graphite rod. Copper is used here because it has very low resistance. It allows current to flow easily into the graphite. Once wrapped, use tape to secure the wire along the body of the pencil. This keeps everything stable and easy to handle. At this point, you have a basic electrode. Now you need a power source. Take 3 9-volt batteries and connect them in series. Stack them so the positive terminal of one touches the negative terminal of the next. This increases the total voltage. Add another wire with alligator clips on both ends. Connect one side of the battery stack to the graphite electrode. Connect the other wire to the remaining terminal. Bring the graphite tip close to the metal clip. As soon as they touch, you'll see sparks. This happens because current flows through a very small contact area. The resistance at that point creates heat instantly, enough to produce a visible spark. Now let's test it in a practical way. Take 2 razor blades and place them together. These are thin pieces of steel, so they respond quickly to heat. Touch the graphite tip to the joint while allowing current to flow. The heat concentrates at the contact point. After a few moments, the metal begins to fuse. Remove the electrode and let it cool. Try bending the blades. They stay connected. This shows that even with a simple setup, you can create enough heat to join small metal parts. But this is just the first version. Now I'm going to show you a more advanced design. Take an old AA battery and carefully remove the outer casing. Inside, you'll find a graphite rod surrounded by carbon material. Remove the carbon powder and clean the graphite rod. This rod is thicker and more durable than the one from the pencil. DIY community. Where are you watching this project from? Drop your location below. Take some baking soda and fill the bottom half of the battery casing. Insert the graphite rod back into the center. Add more baking soda around it. Then apply super glue to fill the remaining space. This step serves 2 purposes. First, baking soda acts as a filler. It holds the rod in place and provides basic insulation. Second, When combined with superglue, it creates a hard, stable structure. The mixture solidifies and keeps the graphite rod firmly positioned. Let it set for a moment. Now take an electrical connector with screws. Wrap a layer of insulating material around the graphite rod, then attach the connector to the top. Tighten the screws so the connection is secure. Next, take a short piece of solid copper wire. Sharpen one end slightly. Then attach the other end to the connector. This copper tip helps focus the heat more precisely. Because copper conducts electricity very well, it transfers current efficiently to the tip. Take another wire with an alligator clip. Strip the end and secure it to the connector. Wrap the wire along the battery casing using tape. This keeps the tool compact and easy to hold. At this point, the upgraded tool is complete. The key to this method lies in understanding the materials. Graphite provides resistance and heat generation. Copper delivers current efficiently. Baking soda and glue create structural support. Now it's time to test it with a stronger power source. Take a 12-volt battery and connect a wire with alligator clips to one terminal. Connect the other terminal to the welding tool. Attach a small piece of solder to the free clip. Bring the copper tip close to the solder. The solder melts almost instantly. This shows how much more heat the system can produce with a higher power source. Test it again with metal. Take two razor blades and position them together. Apply the tool to the joint. The heat builds quickly, and the metal begins to bond. Take a final look at both versions. The first version is quick and easy to build. It's good for small tasks and basic testing. The second version is more stable and powerful. It gives you better control and stronger results. Remove the tool and let it cool. Bend the blades again. This time, the connection is even stronger. The improved design delivers more consistent heat and better control. Now, let's apply this to a real repair. Take a stainless steel mesh strainer with a broken handle. This is a common household problem. Attach one clip to the handle and bring the electrode to the broken joint. Apply solder and allow the current to flow. The heat melts the solder and fills the gap between the metal parts. Hold it steady for a moment. Then remove the tool. After cooling, test the handle. It holds firmly. And just like that, a simple idea turns into a practical solution. If you found this method useful, don't forget to give this video a like and share it with someone who might need it. Thank you for watching, and I'll see you in the next video.